Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 2, Recursive Formulas for Sequences. Classwork Example 1. Consider Achilles' sequence 5, 8, 11, 14, 17. If you believe in patterns, what might you say is the next number in the sequence? Well, 5 plus 3 is 8, plus 3 is 11, plus 3 is 14, plus 3 is 17. I'm assuming that it's an addition of 3, so I would say 17 plus 3 is 20. It says to write a formula for Achilles' question, Achilles' sequence. Okay, so if I write my first term down, it is 5. And then I added 3 to get my second term. So my first term was 5. Second term was 5 plus 3. Third term is 5 plus 3 plus 3. This equaled 8. This equaled 11. So 5, 8, 11. And the next one is 5 plus 3 plus 3 plus 3, which equals 14. And so on and so on. But if I go back to this level here, I can rewrite the 5 plus 3 plus 3 as 5 plus 3 times 2, which equals 11. Okay, or actually it'd be 2 times 3. Does it matter? Yes and no. 5 plus 2 times 3. Okay, so I just rearranged this. So 5 plus 3 plus 3 is 11, and that would be the same as 5 plus 2 times 3. And then 5 plus 3 plus 3 plus 3 equals 14, which would be the same as saying 5 plus 3 times 3. Okay, so what's going on here is, if we were to write a formula, and we could say f of n, or a sub n, so I would write a sub n equals, okay, our terms, and how can I represent this now? What's changing every time? We started with 5, and we added multiples of 3. So it's 3 times, well, 3 times our first term, and since we're on our second term, it'd be the second term minus the first one to get to our first term. So if I made n a sub 2, my second term would then be a sub, well, let's go to the 3. A sub 3, my third term would then be 5 plus 3 times n minus 1, and that would be 2, and that is right here, and that's my third term, because this is my first term, second term, third term. So what's happening is we take our starting point, the multiple we're multiplying by, and we're multiplying by the number of terms one less than the one we're on, if that makes sense. Okay? Okay, so explain how each part of the formula relates to the sequence. To find each term in the sequence, you are adding 3, one less time than the term number, if that makes sense. So here we are adding 2 3's, even though it's the third term. Here we're adding 3 3's for the fourth term, and so on, and so on, and so on. Okay. To get the first term, you add 3 0 times. To get the second term, you add 3 1 time. To get to the fifth term, you would add 3 4 times, and so on. D, explain Johnny's formula. Okay, so this is the formula they're talking about when they say to explain Johnny's formula. So Johnny says a times n plus 1 equals a sub n plus 3 for n greater than or equal to 1, and a sub 1, or a of 1 equals 5. Okay, so what his formula is saying is that to find any term in the sequence, just add 3 to the term before it. So he's taking the term and adding 3. So a sub n plus 1, one term after a sub n. So if this was the fifth term, a sub 5, a sub n plus 1, a sub 5 plus 1 would be the sixth term, a sub 6, or a of 6. So a of 6 equals a of 5 plus 3 for all n greater than or equal to 1, and a of 1 equals 5. So his formula is saying that to find any term in the sequence, just add 3 to the term before it. For example, to find the 12th term, add 3 to the 11th term. A of 12 would equal a of 11 plus 3. To find the 50th term, add 3 to the 49th term. To find the n plus 1th term, add 3 to the nth term. It is critical that the value of the very first term be specified. We need it to get started finding the values of all the other terms. So that's why he said a of 1 equals 5. Exercise 1 and 2. Aquilia, in a playful mood, asked Johnny, what would happen if we changed the plus sign in your formula to a minus sign, or to a multiplication sign, or to a division sign? What sequence does this generate? Okay, so let's do this. So a sub 1 is 5, so my first term is 5. My second term would be a sub 1 plus 1, which is a of 2, which equals a of 2 minus 3, a of 1 minus 3. So 5 minus 3 is 2. And then if I plugged in, I want to know the third term, that'd be a of 3 plus 1, or 2 plus 1, I'm sorry, the third term. The third term would be a of 2 plus 1 equals a of 3 minus 3. I did that backwards. If n is 2, I was right the first time. If we're looking for the second term, it was 2. Third term would be a of 2 plus 1, 3. So we take the second term, a of 2, and subtract 3. Here's a of 2 minus 3 is negative 1. And you keep doing that, and you'd get negative 2, negative 4. Subtract 3, negative 7, and so on. What sequence does a of n plus 1 equal a of n times 3 for n greater than 1 and a of 1 equaling 5? So we're given a of 1 equals 5. So then a of 2 would be a of 1 plus 1, which would be a of 2 times 3. See, I keep doing this backwards. All right. Is that right? No, that was right. So a of 0 plus 1 equals a of 0. All right, and then we would do a of 1 plus 1 would be the first term times 3. So a of 2, 1 plus 1 is 2, this would equal a of 2. A of 2 equals a of 1 times 3. A of 1 is 5 times 3 is 15. Okay, so now if I change this to a 2, that is a of 2 plus 1, which is a of 3. My third term would equal my second term times 3. 15 times 3 is 45. Okay, and then the next term times 3, 135, and so on, and so on, and so on. Part C says, what sequence does a of n plus 1 equals a of n divided by 3 for n greater than or equal to 1 and a of 1 equals 5 generate? Well, we're given a of 1 is 5. And then to find a of 2, that'd be a of 1 plus 1, which would be a of 1. I'm just making n1 here. And a of 1 plus 1 is a of 2, my second term, equals my first term, 5, divided by 3. 5 divided by 3 is 5/3, or 1 2/3, or 1.666 repeating forever. We'll leave it as a fraction since it is non-repeating, non-terminating decimal. Okay, so then if I did the next one, it would be, I'm looking for my third term, which is a of 2 plus 1. Everybody agree with this now? Okay, a of 2 plus 1 is a of 3. So that would equal a of, my n is 2 here, a of 2 divided by 3. So 5 over 3 divided by 3, think of that as over 1, is equal to 5 over 3 times the reciprocal, 1/3, which equals 5/9. So this is 5/9. So dividing by 3 is the same as multiplying by 1/3. All right, so then we're going to go on to the next one. And if I'm looking for the fourth term, a of 4, a of 4 is a of 3 plus 1, which is a of 3 divided by 3. So that would be 5/27, and so on, and so on, and so on. Okay. Number 2. Ben made up a recursive formula and used it to generate a sequence. He used b of n to stand for the nth term of his recursive sequence. What does b of 3 mean? Okay, b of 3 is the third term. What does b of m mean? That would mean the mth term in the sequence. Part C says, if b of n plus 1 equals 33 and b of n equals 28, write a possible recursive formula involving b of n plus 1 and b of n that would generate 28 and 33 in the sequence. Okay, there's probably multiple answers to this, but we're going to stick to arithmetic. It's easier, adding instead of multiplying and dividing or taking powers and that kind of thing. So what they're basically saying is a term, b of n, is 28. Then you add 1, meaning the next consecutive term is 33. So we have a sequence where we have our first term is 28 and our second term is 33, and we want to know what sequence would generate that. Well, if b of n, so we want b of n, our formula to say, well, what are we doing here? How do we find the next term? Well, how did I find 33? 33 is the second term, or b of 2, and this is the first term, or simply b of 1. So how did I get to b of 2 from b of 1? Well, I took b of 1 and added 5. And that's one less term than this term. So if I took whatever term we're on minus 1, which means the term before it, and add 5 to it, then I'd get the next term. Hopefully that made sense to you. So if I was looking for the 10th term, it would equal 10 minus 1. I forgot my b here. It should be b of n minus 1. I would take my 9th term and add 5 to it. So b of 10 would be the 9th term plus 5. Okay. Actually, I didn't want to erase all of that. Just want to erase this. So my answer is b of n equals b of n minus 1 plus 5. So if I check this, b of 1 would equal b of 1 minus 1, which is 0, plus 5. If I change this to a 2, and I'm looking for the second term, it'd be the first term minus 1, or I mean the second term, n is 2, so it'd be the second term minus 1, which is the first term, so b of 2 would equal b of 1 plus 5. Well, b of 1 is 28, so b of 2 would equal 28 plus 5, and thus b of 2 equals 33. So this is the formula. Part D says, what does 2 times b of 7 plus 6 mean? Okay, so what that means is multiply the seventh term by 2 and then add 6 to it. Okay? What does b of n plus b of m mean? Well, b of n plus b of m would be the sum of the nth term and the mth term. The sum of the nth term and the mth term. F. Would it necessarily be the same as b of n plus m? Okay, and that answer would definitely be no. Okay, because let's just say the nth term, let's say n, let n equal 4 and m equal 5. Well, the fourth term in this would be, let me change colors now. First term, second term, we're adding 5 each time. 38, 43, 48, 53. 1, 2, 3. This is the fourth term, and this is the fifth term. So if I took b of n plus b of m, b of n plus b of m, b of n is 43, and b of m is 48, and they add up to 91. But in this case, b of n plus m would be b of 9, n plus m. And the ninth term is 1, 2, 3, 4, 5, 6, add 5, 58. 7 is add 5, 63. 8 would be 68. And the ninth term would be 73. So b of 9 would be 73, and it is definitely not equal to 91. What does b of 17 minus b of 16 mean? It means the 17th term minus the 16th term. Since they're consecutive terms and each term has a difference of 5, b of 17 minus b of 16 would equal 5. Okay, here's example 2. Consider a sequence given by the formula a sub n equals a sub n minus 1 minus 5, where a sub 1 equals 12, and n is greater than or equal to 2. So the first term is 12. So there's the first term. And we're taking, so a term is equal to the previous term minus 5. So what we're doing is subtracting 5 each time. So, or adding, yeah, subtracting 5 each time. So we get 7. So a sub 2, let me just write this for you just so it's not confusing. So if I were looking for the second term, my n is 2. So a sub 2 equals a sub 2 minus 1 minus 5. Okay, for some reason my pen always snaps to what I previously wrote. So a sub 2 equals a sub 2 minus 1 minus 5. Let me move these over here. Okay, well, that means that a sub 2 equals a sub 1 minus 5. 2 minus 1 is 1. So the first term minus 5 is 7. If I were looking for a sub 3, that would equal a sub 3 minus 1. A sub 3 would equal a sub 3 minus 1 minus 5. So in other words, a sub 3, my third term, would equal a sub 2, my second term, minus 5. My second term, so a sub 3, would equal my second term 7 minus 5. So my third term equals 2. And once we get a feel for this, we do a few of them, we find out what our difference is, our common difference. Then 2 minus 5 is negative 3, negative 8, negative 13, and so on, and so on, and so on. Now it says to write an explicit formula. So we have a function, a sub n, equals our first term, 12, minus, and our difference, common difference, is 5, and we're multiplying it by the previous term, n minus 1, for n greater than or equal to 1. So if I was looking for my second term, it'd be 12 minus 5 times 1, or 12 minus 5. If I were looking for my third term, it'd be 12 minus 5 times 3 minus 1, or 2. 5 times 2 is 10. 12 minus 2, 10. 12 minus 10 is 2. So the number of terms away from our first term is a multiple of 5, decreasing by a multiple of 5 each time. Now it says to find a sub 6 and a sub 100. So now that we have this formula right here, now we can find any value. So a sub 6 is going to equal, let me try to make this neat, equal, a sub 6 equals our first term minus 5 times our n, which is 6, minus 1. So a sub 6 equals 12 minus 5 times 5, or a sub 6 equals 12 minus 25. So a sub 6 equals negative 13. And that's right here. 1, 2, 3, 4, 5, 6. It checks. Okay. A sub 100. A sub 100 equals 12 minus 5 times our n, which is 100, minus 1. So a sub 100 equals 12 minus 5 times 99. So a sub 100 equals 12 minus 9 times 5 is 45, carry the 4. 9 times 5 is 45, plus 4 is 494. So a sub 100 equals negative 494. 12 minus 494 is a negative 482. Okay. Small error right here. Hello, eraser. Okay. 9 times 5 is 45, and therefore this is negative 483. The reason I knew I made a mistake there is because if you look up here, once we went negative, our number will end in 3, 8, 3, 8, 3, 8, 3, 8 forever, and I had a 2, so I knew I had made a mistake. So those are the things you need to look at when you're doing math. Look for patterns, and where did that 2 come from? If we're going from 3 to 8, 3 to 8, 3 to 8, which is what subtracting 5 does every time. Exercise 3.6. Now it's your turn to try it. Pause the video, see how you did, then come back and we'll check. Okay, one of the most famous sequences is the Fibonacci sequence. Okay, this is used all over the place, including trying to figure out the stock market. Okay, so 1, 1, 2, 3, 5, 8, 13, 21, 34. What's going on here? We take our first term and we added 1 to it. Take our first term, we added 1 to it. Take our last term, we added 1 to it. Take 3 and add 1. Uh-oh, it's not 4. Take 5 and add 1. It's not 6. What's going on here? Well, 2 is the sum of these two. 3, let me make that circle bigger. So the Fibonacci sequence says take your first term and add the prior, take your term and it's the sum of the previous two. So 3 is 1 plus 2, 5 is 2 plus 3, 8 is 3 plus 5, 13 is 5 plus 8, 21 is 8 plus 13, and 13 plus 21 is 34. Okay, so that's the Fibonacci sequence. It says f of n plus 1 equals, so that's, for example, say n was 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is my ninth term. So f of 9, which would be 8 plus 1, is my eighth term, 21, plus my n minus 1. If n is 8, that'd be 8 here. So the ninth term equals the eighth term plus the seventh term, where f of 1 is 1 and f of 2 is 1, and n is greater than or equal to 2. Okay, that's kind of neat, isn't it? So it says, how is each term of the sequence generated? By adding the previous two terms. Okay, by adding the previous two terms. Each sequence below gives an explicit formula. Write the first 5 terms of each sequence, then write the recursive formula for the sequence. Okay, so write the first 5 terms. So a sub 1 equals 2 times 1 plus 10. So the first term is 2 plus 10, or 12. A sub 2 equals 2 times 2 plus 10. So a sub 2 equals 4 plus 10. So a sub 2 equals 14. Okay, so I know my first term is 12. I know my second term is 14. My third term, a sub 3 equals 2 times 3 plus 10. So a sub 3 equals 6 plus 10. So a sub 3 equals 16. Okay, so now I have 12, 14, 16. Well, if I keep doing that, all I'm doing is taking multiples of 2, so that adds 2 to 10 each time. So my first term is 12. My second term is 14, 16, 18. Write the first 5 terms, 20. There's my first 5 terms. Then write a recursive formula. Okay, so the recursive formula would be a sub n equals. And what do recursive formulas look like? Well, if we looked up here, it is the first term and then what we're doing to get the next term. So I would say a sub n equals 12 plus, and then what are we doing to n each time? 2 times the previous term. Okay, a sub n equals 1/2 to the power of n minus 1 for n greater than or equal to 1. Okay, so again, I'm just going to find a sub 1, which equals 1/2 to the power of 1 minus 1. So a sub 1 equals 1/2 to the power of 0. And a sub 1 equals 1. Remember the power of 0. Oftentimes I ask students and I'll say, what is such and such to the power of 0? And their initial answer is always 0. No, anything to the power of 0 is 1. So a sub 1 equals 1 because 1/2 to the 0 is 1. A sub 2 equals 1/2 to the power of 2 minus 1. So a sub 2 equals 1/2 to the first power, or simply 1/2. a sub 3 equals 1/2 to the 3 minus 1. So a sub 3 equals 1/2 squared. So a sub 3 equals 1 squared over 2 squared. A sub 4 equals 1/2. Let's make that a little bit neater. It equals 1/2 to the 4 minus 1, or a to the 4, or a sub 4, I mean, equals 1/2 to the power of 3. So a sub 4 equals 1 cubed over 2 cubed. Okay, so now we have to write a recursive formula for that. So a sub n equals my first term, 1 plus okay, we're not adding each time. 1/2 plus, so we're not adding, they're getting smaller. We're getting smaller and smaller and smaller. 1/2, 1/4, 1/8. So what's happening next would be the 16th, then the 1 over 32, 1 over 64, 1 over 128, 256, 512, 1 over 1024, and so on, and so on, and so on. We're getting closer and closer and closer to 0, all right, but never getting there. So how can we write this? What are we doing each time? We're taking the prior term and dividing it by 2. So we're taking the first term and then dividing it by 2. So how can we write this? A sub n equals, let me think about this. Okay, so I just kind of played around with this behind the scenes a little bit because these can be a little tricky sometimes. So I wanted to include the first term, but that's not relevant because it's 1, and 1 times anything is 1. But this is what we could possibly have used. So a sub n, a term, any term, is equivalent to 1 times, or that first term divided, or that the previous term divided by 2. So I don't really need that 1 there. So it would be a sub n equals the previous term, a sub n minus 1 divided by 2. B. All right, 1/2, 2/3, 3/4. Oh, I forgot A. I didn't do A. I came down here and I did all my work where A is supposed to be. So let me get this out of the way, and we will do A once this is out of the way of A. All right. For sequences, write either an explicit or a recursive formula. Okay, so for this sequence here, to make a number go from positive to negative, we can multiply it by -1. So 4 times -1 is -4. But if I multiply 4 times -1 times -1 again, that would be 4 times -1 is -4, but -4 times a -1 is +4. And then if I did it again, 4 times -1 times -1 times -1 equals positive times a negative is positive, is negative, negative times a negative is positive, positive times a negative is negative, and 4 times 1 times 1 times 1. So what's happening is it's oscillating back and forth between -4, 4, -4, 4. And what we're doing is we're taking multiples of -1. So with that said, that was just an example. I could say a sub n equals -1 to the power of n plus 1, where n is greater than or equal to 1. So if I start with 1 plus 1, that's 2. -1 squared is 1. So my first term would be 1. So if I look for my, let's check my fourth term, was -1. 4 would be a sub 4 equals -1 to the power of 4 plus 1, or 5. And when you take a negative to an odd power, it stays negative, so that would give me that negative. So the answer is a sub n equals -1 to the n plus 1, where n is greater than or equal to 1. Okay, this one, if you notice, we're adding 1 each time to the numerator, and we're adding 1 each time to the denominator, but our denominator started out 1 more than our numerator. So our first term could be a sub n equals, let's see, if n was 1, our first term is 1, and our bottom would be 1 more than that. So if n is 1, the bottom would be 1 plus 1, or 2. So a sub 1 would be 1 over 1 plus 1, which is 2. And a sub 3 would equal 3 over 3 plus 1, which is 4. And our third term is definitely 3 over 4. So it's going to be a sub n equals n over n plus 1. But you have to say where n is greater than or equal to 1. Okay, number 6. Lou opens a bank account. The deal he makes with his mother is that if he doubles the amount that was in the account at the beginning of each month, by the end of the month, she will add an additional $5 to the account at the end of the month. Let a sub n represent the amount in the account at the beginning of the nth month. Assume that he does, in fact, double the amount every month. Write a recursive formula for the amount of money in his account at the beginning of the n plus 1 n-1th month. Say that again, 3 times fast. Okay. So, let a sub n represent the amount in the account at the beginning of the nth month. Okay, so since we already know that a of n is the amount in the account at the beginning of the nth month, we want to write a recursive formula about money for the amount of money in his account at the beginning of the n plus 1th month. We want it to say a of n plus 1 equals. So what are we doing to the account each time? We're taking the prior month's amount and doubling it, and if that happens, we get a bonus $5 from mom. So there it is. But you also have to say where n is greater than or equal to 1. Can't have negative months or 0 months. And a of 1 is the initial amount. So a of 1 is the initial amount. Okay. B says, what is the least amount he could start with in order to have $300 by the beginning of the 3rd month? Okay, so 3rd month is a of 3. That's the 3rd month. And that equals, well, in order for this to equal 3, this is where it might get a little confusing to you. In order for that to equal 3, we want n to equal 2. So it's going to be 2 times a 2 plus 5. Okay, so a of 3, a sub a of 3 is going to equal 2, and then a of 2 is 2 times a of 1, first month, plus 5, and then we add 5 to that. Okay? So it says here the deal he made with his mother is that if he doubles the amount that was in the account at the beginning of each month, by the end of the month, she will give him $5. So if I double my first month, I get $5 at the end of the first month. So then if I double that amount, she'll give me $5 again. So that's why there's this 2 times the quantity from the first month with the bonus, So the second month is 2 times the first month plus another $5. Okay, so now we're going to substitute in an A. Why did I write an A? We're substituting in A sub 3. We want to have $300 at least. Okay, the least amount. So that would mean that the amount's got to be greater than or equal to 300, and it'd be 2 times the quantity, 2 times A of 1 plus 5 plus 5. Okay, just made room for us here. All right, so continuing, 300 is less than or equal to, and now I'm just going to simplify this. Well, what's our only unknown? Our only unknown is our first month, A sub 1. So I'm going to distribute, and I'm going to get 4 times A sub 1 plus 2 times 5, which is 10. And that is not in, the next 5 is not in parentheses, so that's plus 5. So that's going to simplify to 300 is less than or equal to 4 of the amount in 4 times the amount of the first month plus $15. Okay, 5, 10, 15. 3 bonuses from mom. And then I need to subtract 15 from both sides. I'm trying to solve for A sub 1, my first month initial starting value. These cancel. I get 4 times A sub 1, or A of 1, and 300 minus 15 is $285. I then divide by 4 to find out what I had to start with. So my first month, A of 1, has to be greater than or equal to 70. 7 times 4 is 28, no remainder. 4 goes into 5 once with a remainder of 1. Okay, so let me do it over here just so you see what I'm doing. 285. So 7 times 4 is 28 minus, and we get 0, bring down the 5. 4 goes into 5 once. Remainder of 1, bring down a 0. 4 goes into 10 twice. 4 times 2 is 8. Subtract, bring down another 0. 4 goes into 25 times. He needs to have at least $71.25 in his account in order to double it every month, and mom giving him $5 in order to have $300 by the beginning of the third month. Okay, that is the end of lesson 2. Review your lesson summary and go to your problem set.